Alright guys, so for square roots, we need to understand when they show up, what are their properties, and why they're even useful in the first place. Okay, so here I have two examples, one example on the left and another on the right. Let's look at the example on the left first. So, the example on the left, we have 3x equals 6. And if I ask you, how do you solve this? You're all going to say, oh, you just divide by 3. So you divide by 3, you end up with x equals 2. Now, a lot of you know this, but maybe you don't understand fully why, okay? Why do you divide here? You divide here because you want to get x alone. And what is x being sort of affected by? It's being affected by this 3. And this 3, what is it doing to the x? This 3 is multiplying the x. And so what is the opposite of multiplication? Division. So that's why you divide, because it's being multiplied by 3. This goes away with this. You end up with x equals 2. So the key idea here is you divide because division is the opposite of multiplication. And now when we talk about square roots, it's no different, okay? Here I have x squared equals 4. And so what is the opposite of squaring something? The opposite of squaring something is doing the square root. So if you do square root here, what happens? Well, this goes away with this, and you end up with x equals 2. Why does it work that way? Because the square root is any number multiplied by itself equaling what's inside. And so 2 times 2 gives you 4. So that's why the answer is going to be 2. Now, some of you math geniuses out there might be thinking, all right, I know that 2 times 2 equals 4, but technically, shouldn't I have that negative 2 times negative 2 also equals 4? And I would say, damn, you are right. Positive, positive 2 multiplied by itself gives 4, and negative 2 multiplied by itself also gives 4. And so the answer here is not just 2, it's actually positive or negative 2. Okay, why? Because of this here. All right. Now, let's understand a little bit better like why it's a number multiplied by itself twice. Okay? So, in math, all right, there's a lot of things that we out of like convenience, we write them in a certain way. For example, let's say that I have a parabola, okay? Let's remember that parabola looks something like this. See? Let's say that we have a parabola that's, I don't know, 3x squared plus 2x plus 1, okay? And we go term by term, see? And I ask, this x is to the power of what? Well, you would tell me that this x is to the power of 2. What if I ask you, this x to the power of what is it? Some of you might be thinking 0, some of you might be thinking 1. In this case, x is to the power of 1, see? Now, in math, okay, you write it like this, without the 1, see? But technically, there's like a secret 1 or so to say, all right? And technically, this 3 is to the power of 1, okay? This 2 is to the power of 1. This x is to the power of 1. This 1 is to the power of 1, okay? But out of convenience, you write f of x equals 3x squared plus 2x plus 1 instead of putting all these ones that are sort of implied, okay? They're given, but they're hidden, okay? They're there like behind the scenes, okay? You know that they're there, we just don't write them, okay? Why is this relevant? It's relevant because when we're talking about square roots, for example, the square root of 4, and you tell me that the square root of 4 is plus or minus 2, because it's any number multiplied by itself, the reason for that, okay, is because here in math language, you're asking what number multiplied by itself twice gives 4, which is very different than if I ask you one number multiplied by itself 3 times gives 8. So square root of 4, which is the same as, just putting it like this, okay, this is the same as this. That's what I'm trying to say. Okay, this 2 is hidden, which is the same as these ones over here being hidden. Okay, it's no difference. Out of convenience, you don't write it. Okay, but what this 2 tells you is how many times a number needs to be multiplied by itself to give you what's inside. So here in math language, okay, right here in math language, this number 4 multiplied by a number twice has to give you 4. See? So what is it? Well, 2 times 2. See? It's twice, ¿cierto? Twice because of this 2, and 2 because 2 times 2 is 4. Down here, it's no different. One number multiplied by itself 3 times gives you 8. 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. See what I mean? So that is what the little number is doing, okay? Why can this also be relevant? Well, eventually, some of you might be looking at stuff that looks like this. You might be looking at, I don't know, x to the power of 1/2. And you're telling me, dude, what the hell? Like, what's going on? ¿Cierto? X to the power of 1/2 is square root of x. And you might be thinking, why? Okay, why is that happening? Where does the 1 come from? Where does the 2 come from? The 2 comes from this 2 here. And the 1 comes from this one here. Ah, so that's why I was talking about this thing here and this thing here, okay? All right, so let's do another example. Let's say I have square root of, I don't know, 3 on the outside and x squared. How much is this? This is going to be da, 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 x to the power of 2 divided by 3. What if I have it the other way around? This would be that, okay? And actually, this example here is the same as this example here. All right, so that's a little bit about the properties that I think are like weird with square roots. There's other stuff you can encounter. Okay, there's other stuff that you can encounter that might look like, but it's just the properties that you end up Googling on Google. Okay, you can have stuff like, I don't know, square root of x divided by square root of y. So this is the same as everything being square rooted, which, if you keep this in mind, ¿cierto? X 1/2 divided by y to the power of 1/2 is the same as everything 1/2, okay? All right, all the other properties I think are fairly easy to understand and come by. I'm going to leave this video here for square roots 101 because I think this is the confusing parts, the things that students tend to not understand, okay? So I'm just going to leave that there. And one last example, okay? Just one last example. Just because I see it happen a lot. Square roots of x squared is just going to be x, okay? And why? Because x times x gives you x squared. Cool. This is pretty obvious, see? Well, you have to keep this in mind because when you start encountering stuff like square root of 9 squared, this is just 9, okay? Square root of 536 squared, how much is it? 536. All right, that's the kind of stuff that can help you sort of remember, keep in mind, etc. Okay? Anyways, I'm going to leave that video here. I hope it helped. If you have further questions, I'll be around. Let me know. Peace.